Yan. So today we're going to talk about the last technique on getting 3D shape, and it's called shape from structured elimination. And there are many ways to do this, but the particular technique that we will discuss today is phase shift profilometry algorithm. So it has three parts. You first do a face wrapping, face unwrapping, and then a face to height conversion. The setup is as shown. So you have a 3D object, and there's a projector which is in charge of projecting a pattern on the surface. And we know, for example, if we project a straight line, if the surface here has some structure, or rather some texture or shape, that straight line will not look straight. Instead, it will conform to the curvature of the object. So the clue to the shape of the object is on those shifts on the straight line. It will be captured by a camera, normally at the same plane as the projector. Okay, first unwrapping goes like this. The reason why it's called the structured light illumination technique is because you are projecting a certain pattern. So structured illumination is just a fancy word for pattern. And so the pattern that we are impinging here is a sinusoid. And then not only one, but there would be 4 sinusoids. And depending on the type of algorithm, you can have different numbers of sinusoids. This one is 4 sinusoids. Each of those sinusoids are shifted by pi over 2. Okay, so there's each of them phase shifted by pi over 2. Okay, so you're projecting a sinusoidal image. So this is a bias. This is a constant bias because normally a sinusoid would be just negative and positive. But technically, if you have a bias, constant bias, parang ito yun. And then this is the intensity you will set for the cosine. So this is just a constant bias. Then this is the intensity of the cosine. And of course, you set a frequency. So itong part na to is 2 pi f times x, y, right? So this part here. And then a phase shift. These are the ones that you project, okay? All right, now, in this phase shift as well, dito embedded yung shape ng structure, or shape ng surface. Any phase shift due to the shape of the object will reflect in this phase shift part. So normally, kung wala, the 2 pi f xy lang to. Okay. However, with some height, there would be some other terms here. Now, we express equation 2 as, wait lang, not express equation 2, but essentially we can write it as di ba? Pag phase shifted by pi over 2 ang cosine, magiging sine siya. And then there will be a negative sign, right? Pag phase shifted ang cosine with a pi, it becomes negative pi. Negative cosine, sorry. Okay? And again, pag cosine is something plus phase shift ng 3 pi over 2, it becomes positive sign. Okay? Phi. So, rewrite natin tong terms na to in terms of what happens if you have a pi over 2 pi, 3 pi over 2 shift. Okay? And now, we can subtract like terms. For example, take I4 and subtract I2. I4, I2. O mawawala yung, mawawala yung I0. Tapos magiging 2 times I mod ito. Okay? Kasi plus minus minus. So magiging 2 times I mod times sine phi. Same with I3. I1 and I3. No? If you subtract the 2, then you will get 2 I mod cosine of P. Now you can take the ratio of these two, because that's a sine and that's a cosine, then that would be a tangent. And then you can calculate the phi. Right? So, una mo na, magka-cancel na yung 2i mod, no? So, that means hindi nagmamatter kung ano yung intensity, amplitude ng sine, cosine, kasi it will cancel anyway. So, in the phase, just take this. And that's it. We now have the phase information. This is where the height is embedded. Okay. That's it. Right? That's it. So, how does this go? Pag gagawin natin is, you have 4 patterns of sinusoids. Each of these 4 patterns may phase shift na pi over 2. So you have 0 phase shift, pi over 2 phase shift, pi 3 pi over 2. And then you're going to project these patterns from the projector on the surface. So in this case, what is being projected upon is a cylinder, no? Cylinder lying on its side. And so as expected, instead of seeing straight lines, we see curved lines, and it indicates to us, it bears the information about the height. So from a straight line to this, nagkaroon ng phase shift. Okay? Calculating from these 4 images, so this is I1, I2, I3, I4, ipapasok mo dito. So you will subtract I4 from I2, you will subtract I3 from I1. And you will get the ratio and get their inverse tangent. And you will end up with this image, with a phi. This is a phase image. Okay? And this is called wrapped phase image. Because once it gets to, diba, pag inverse tangent, mag-infinity yan. So, mag-roll over yan ulit to minus pi to pi. Kaya may itong mga discontinuities na to ay it's a property of an inverse tangent. We have to get rid of this because ano lang to it's an artifact of it being an inverse tangent. The way of removing this is called phase unwrapping. Okay, in phase unwrapping, itong mga parang sharp discontinuities na to, or actually that's an indication of a 2 pi step. So in phase unwrapping, in any phase unwrapping procedure, what we usually do is we look for these parts and we add a 2 pi to the value. Remember, this is a phase image. So these pixels correspond to, the value of these pixels correspond to the phase. So when you reach this parang discontinuity, you put the 2 pi. You add a 2 pi dun sa mga susunod na pixels na. Once again, pag nakapunta ka na dito, you add another 2 pi, add another 2 pi, add another 2 pi, 2 pi. So you can imagine parang nag-accrue yung 2 pi na yan, But the moment you do that, ang itsura na ng phase shift image is this. Sorry, phase shift image. Ng phase image would be this. And this is what is called an unwrapped phase. Okay? All right. And then, technically, we have to remove, all unwrapped images would have a ramp. Kasi di ba para kang nagdagdag ng 2 pi here, tapos ito meron ng 2 pi, tapos dinagdagan mo pa uli ng 2 pi here. So nag-accrue o nag-accumulate yung 2 pi, which is why normally you would see something like this, the shading is increasing. So totoo lang, ibig sabihin yan, it's riding on a ramp. It's riding on a ramp, which is increasing because of the fact na when you unwrap, you're adding 2 pi each discontinuity step. Actually, we will have to remove that ramp. Once we remove that ramp, we can recover the shape. What's left is the shape, and this is what our construction looks like. Now to the phase to height conversion. In the simplest approximation, the depth z is just proportional to the difference in phase. This difference in phase, kasi ito is actual phase, the difference in phase is the phase difference between flat reference surface and this phase. And then there's just a proportionality constant. In some very controlled instances, this is valid. So for the purpose of this exercise, we will just assume that this is so. Okay, so it's important that you take a reference image. So here's an example of an actual capture. A reference image is anything flat, no? So what you do is, once again, you take 4 images of this flat reference, 4 images corresponding each to the projected sinusoid. And you also do that for the object. Again, the same sinusoid, and then same sinusoid shapes. Yeah. And then and this is already actually a face image. Hindi ito yung projected image. Ito na yung face image na na-calculate. You unwrap this face image, unwrap this face image. Okay, so this is for the reference, this is for the object. And so what you do is, this is the object face map, this is the reference face map. You subtract the two, okay, and what you get is the output face map. So this is already proportional to height. We just need to find the conversion factor K. You know what this is? These are the pebbles on the wall of NIP. So this was done by my students. They tried this on the wall because it's a nice pebbly structure. And here you can see that you captured the pebbles, each of the pebbles. Phase shift profilometry is quite accurate because it's per pixel, unlike stereometry, where the height information is available only to those points that you click. No? In phase shift profilometry, it's pixel rich because pixel per pixel, there is an estimate for Z. Okay? And that's how you do it. It's as simple as that. So to review. So how do you do phase shift profilometry? Sa taas. So it is structured light illumination. You prepare 4 sinusoidal images. Bahala ka sa frequency. And normally, the higher the frequency, the finer details you can get. But it comes with the cost of, having a lot of discontinuities. Prepare 4 cosine or sinusoidal images, each shifted by pi over 2. Okay. And then project this on the object, capture an image. 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 Okay. And then because of properties of sine and cosine, you can rewrite these phase shifts this way, which you can further create a difference like this, which you can further combine as an inverse tangent. And the height information of the surface is embedded somewhere here. And you take, this is phase. The phase difference is when you take the face of the object and the face of the reference and you subtract them, and then that phase difference there would be proportional to Z. Any question? So we did this a lot of times. We did this actually on different objects in heritage objects. No? So the sample that we will use today is the Tikao stone. So I've already prepared. This was, I think, back in 2011. We went to Tikao Masbate to get these images. So these are already phase shifted images. Okay. So we can download this and use this. So hindi lang pansin na gumagalaw yung image, yung sinusoid, but gumagalaw yan, promise. Okay. So what is the Tikao stone? The Tikao stone is a limestone found in Tikao Island, Masbate province, and it bears some Baybayin writings. So they think this is quite ancient and that there's a message in this stone. I think one of my colleagues was able to decipher this because anyway, the Baybayin is our ancient syllabary. Even before the Spaniards came, we already have our own writing method, no? Written communication. And I think what was written here is Tahumanan Nakatana. Because it's a syllable, no? So syllables to, by the way, it's upside down. Medyo nakabaliktad because this flat edge here, that's the one that we can land on the platform. Okay, so here's the sinusoid that you see at the background. It's impinging on the surface. Okay. Meanwhile, if you could kindly upload those images in your MATLAB workspace and start opening them, assign them as I1, I2, I3, I4. I think it's very straightforward. Don't you agree? The algorithm is pretty straightforward, diba? So go ahead and first upload these images anyway that those 1, 2, 3, 4 correspond to the same phase shift. No? Once you've uploaded them, the next thing you do is first convert them to grayscale, grayscale, grayscale. Also, the other thing that you need to do would be, not all of the parts of the image are important. So we can probably crop just an itty bitty portion of that they want to 3D. And also that will reduce the time. Okay. Now that you've grayscaled, cropped the area of interest, you just perform this. Image 4 grayscale minus image 2 grayscale. Image 1 grayscale minus image 3 grayscale. And then get their ratio and get their inverse tangent. And voila, you get the phi. I think it's pretty straightforward, don't you agree? Okay, there would be, unfortunately, I can't find the reference image here, but we will see that once we've unwrapped it, it would look, once we've computed the phase, it would look something like this. Medyo paganyan siya, medyo may naaninag na kayo, but actually it is riding on a ramp. We can estimate that ramp actually. We can just estimate that ramp and subtract it from the image.
Ma'am, we can't see your screen po.
Hello, kanina pa ako nagsasalita. Ganun.
No, just now. You ended it, I think, when you opened MATLAB online.
Huh?
Kanina you were, but you stopped it.
Hello? Can you see my MATLAB?
No.
There's an issue with MATLAB online. Please contact support. Okay. So I've not been sharing my screen. I've been pointing on something that I've not been sharing. Okay, sige, wait. Okay. Again, as I was saying, I think it's pretty straightforward. If while you're waiting for me to more prep on the other computer, it's pretty straightforward. Don't you agree? Load the images, picture 1, 2, 3, 4, convert them to grayscale. You can also limit the area of analysis by cropping the same area. Wait lang. And then perform this. Simply perform this. Image 4 minus image 2 grayscale. Ha? Image 1 grayscale minus image 3 grayscale. Get the ratio, get their inverse tangent. Voila, you have your phi. Okay? And then as I was saying, once you get the phi converted, you need to unwrap it. There are phase unwrapping algorithms within MATLAB. Once you've unwrapped it, you will normally see something like this. Unfortunately, I wasn't able to find the reference object for this, but that's okay. We can estimate that ramp based on this image. So we'll just estimate that ramp and we will subtract it, and hopefully we get a 3D image of the etchings on the stone. Okay, while you're waiting for me to prop, the computer is starting up. You can start uploading your picture 1, 2, 3, 4 image.
Ma'am, is there a shortcut to like make the cropping the same for all, or is it okay if it's just like approximate?
That should do it. Okay. Alright. So somewhere here, kasi nandito na sa directory na to, anyway, nandito na yung picture 1, picture 2, picture 3. So, I1 equals imread picture 1 JPEG. Copy paste natin ito. Let's see. Na. Control C, Control V, Control V, Control V. 2, 2, 3, 3, 4, 4. Ngayon, meron din RGB to gray, kung hindi ako nagkakamali. RGB to gray. Para grayscale agad. Okay. Okay, so pagka-imread natin, I think pwede nating ganito. Try lang natin, ha? Okay. Let's try this one line here. There, unsigned int 8. That works. Okay. So, Control C. Para diretsong grayscale. Otherwise, colored siya. As you have seen in the image earlier. Colored itsura niya. There. Tapos, takpan natin to. Yan. There. Now, it's possible to just crop a section. Kasi ayaw naman natin ng lahat. Kasi masyadong malaki, guys. So, tignan nyo. 244 by 3264. And the image here, if we show it, show I1, is medyo, most of them are not useful. So if we want, we can crop a section, whichever we want, right? Okay, so we'll close this. Let's crop. So how do you automatically crop and make sure that the crop section that you get would be the same as the crop section in the others? So there's a way, no? So if you look at the imcrop technique, help imcrop here, it actually gives you flexibility to get the rectangle that you chose. Ganito, when you imcrop, you can keep the cropped image as well as the rectangle information. And then you can use that rectangle information to crop the succeeding images. Isn't that nice? So you just choose from one and you get for all. So how do we do this? So let's say J1 is equal to, we would have to need to J1, then the rectangle. This is a variable which is equal to, when you crop something, di ba, meron kang square. So that square has an origin xy and the width and the height. So you just specify the origin xy. The origin is always the upper left corner, and the width and the height. No? So by calling imcrop this way, you actually preserve the rectangle information which you called. So imcrop I1. Okay. Now, when you call this, it will show the image, and then you will be asked to crop. Okay. So once we get that, we are good to go. J2 would now just be imcrop rect. I2 rect rectangle, the same cropping rectangle that you chose earlier. Isn't that cool? I3 rect and J4 calls imcrop I4 rect. Isn't that great? Okay, let's see if this works. So let's run this section. Run this section. We have it all here. Now let's run this section. There. J1, image 1 is shown, and then we can choose. So I don't know, maybe this one. Yeah. And then when you draw the rectangle, right click and click crop image. And put this aside, we see that it's already here, J1, J2, J3, J4. And if you want, we can show all four, no? Again, you can do a subplot. Subplot 2, 2, 1, im show J1, and do that 4 times. Control C. Then, itong subplot na to, it will show a figure in a 2 by 2 matrix. And then this number that I'm changing is the placeholder. And the placeholder is just, kung saan may lalagay, 1, 2, 3, 4. Okay, so let's run this again. Run section. And then I can pick wherever, like this, perhaps. I click crop image, and then there you go. Okay, notice that the sinusoid has shifted, no? You notice that? Gumalaw na siya, no? I have a creeping suspicion that this image is baliktad. Teka ha? Hindi naman. Hindi, tama lang. Sige. Let's hope for the best. Okay. Okay, sige. Tama naman. Okay. Now, let's calculate insert section the face. V equals ano ba yun? Arctangent. Let's insert section. So sabi doon, una muna kunin natin yung nakalimutan ko na. Ano yung sabi natin doon sa Google Drive, slides. Okay. No. Hindi siya Google Slides. This is Classroom. Let's go to Classroom. And then we're looking at shape and structure. Okay, sabi doon, I4 minus I2, I1 minus I3. Okay, so phi numerator, ito na muna, is equal to J4 minus J2. Tama ba? Oh, by the way, since eventually we're going to make this into arctangent, we have to convert this into double. Kasi ngayon, unsigned int siya eh. Okay? Or we can first do this. No? May isa? Sabi doon? I1 minus I3. Okay? Denominator is equal to J1 minus J3. Okay. All right. Remember, please be mindful that these are unsigned integer 8. And we have to convert them into double so that we can perform the next part, the arctangent. Now let's look at how arctangent is used. Arctangent is this. Inverse tangent, the results is in radians, no? Okay. Meron ding maraming arctangents eh. So there's an arctangent 2. It's the quadrant arctangent of the elements of XA. I think we want to do this. The sign matters. So let's use arctan 2. Ano tong arctan 2? Hindi ko tayo alam. In degrees. So we don't want degrees. So just want so let's do this. Phi is equal to arctangent 2. Now, again, bakit 2? Kasi 4 quadrants. It will give us a number in the range negative pi to pi. No? Of double ng num. Okay? And remember this. Element per element divide by the double of the denominator. Element per element divide. So there's a dot there. Point per point. Okay. Oh, let's see if it works. Okay. Run section. Bakit po? Oh! Arctangent 2 requires that we give the y and x. Oh, I'm sorry. We can't do that. Can we do that? No, we can't do that because we don't have xy. So we're supposed to just do arctan. Sorry. And okay. All right. Wala eh. Makukuha lang natin sana yun kung may y and x information tayo. But this is not because this is just intensity values. Okay? So, run that. And apparently, we're done. Nakita natin yung phi. Would you like to see how phi looks like? So, figure. Now, I would suggest you use image SC because this is not an unsigned integer 8 thing. With image SC, you can see it as false color. Okay, again, let's run this section. And there you have it. See? Pag scale natin to, false color lang to, no? And then if you put the color bar, you will see the values of the face. Okay. All right. Now, now that we have the face image, Lily and I would like to unwrap the face. So unwrap face. Now there are face unwrapping. We don't unwrap. Yan. Meron mga ganito. Meron mga built-in unwrapping algorithms. Unwrap P unwraps the radian face angles in a vector P where the jump between consecutive angles is greater than or equal to pi radians. Unwrap shifts the angles by adding multiples of 2 pi until the jump is less than pi. Okay. Okay. Let's see if this works because hindi pa yung lumalabas dito eh. Anyway, let's try. Okay. C object is equal to unwrap phi. That's it. Well, let's run first this section to see if there's an error. There seems to be no error. So let's go ahead and display this as another figure. Ouch. Okay, let's run this section again. Oh, hindi siya nagdagdag ng phase shift. And the reason why is dahil ang phase shifts niya dito ay less than pi over 2. Okay? So, di ba ang pi is 3.14, 1592, etc., etc.? Apparently, the phase shifts that we have here jump already at pi over 2. Pi over 2. Which is sad times because we have to do it for pi over 2. Pi times 2. 2 pi. Oh, no, sorry, pi, 3.4. Do you understand what I'm saying? I mean, these discontinuities don't even reach pi. Instead, these discontinuities are actually pi over 2. So what do we do there? I don't know. Let me see. Unwrap, please. Let's go back to the help. Okay. Compares the jump between two elements to threshold toll instead of the default value. Oh, if you specify a jump threshold, unwrap uses. Okay. I suppose we have to tell it to put. Okay. So, ang tolerance natin dapat ay let me see. Hanap ako ng example niya rito. Well, try natin. Try natin if it works. Okay. Are you still with me? Nakita niyo ba yung ginagawa ko?
Yes, ma'am.
Let's say, ang tolerance, pi over 2. Pi divided by. Okay. Let's see what happens to this pi. Sad times. Ayaw pa rin. Okay. Let's take a look at the color bar. Sad times. Ba't hindi niya kaya na-connect yung... I have to look for a different unwrapping algorithm, guys. Ayun na eh. Wait lang ha. Oh, what arctangent shall we use? Okay. Now I get it. Okay, I'm gonna do this. Arctangent 2. This one is... Pag tangent kasi, di ba, it's y over x. Or, sorry, y over x, ano? Tama? The y is, alam ko na. Di ba, the y is the sine part. So, the y is this part. And the cosine is the x part. Okay. So, perhaps, what we do is we call arctangent 2, but we will call this to be the x part. Diba? Ito, oh. Ay, wait. The y part. Oh. And the x part. Ay, tama na pala yung kanina. Control Z. Paalisin lang natin to. We will not do element per element divide. Instead, we will do this. Again, the numerator is the y part because this is the sine. And this denominator is actually the x part, which is the cosine. Okay. Now, before we do this unwrap phase, let's redo this. So, 2, 3. Did I overlap some figures here? Okay. Figure 2. Sige. Try natin Let's run this section. Okay, let's look at the color bar. Ganun pa din eh. Patay, paano yan? Ang kanyang set ng unwrapping ay dito. Okay. right. Unfortunately, even if we do this, should still get the same. Dahil 1.5 pa rin yung ano niya. Okay. Teka lang guys, just figuring out what's happening. Okay. So this is identical. This is not looking good. This is the same color bar. Yes, there was no unwrapping that happened. Dun 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 dun. Lapit na. Unwrapping lang. Okay, let's figure this out. The problem with the unwrapping is that it doesn't see this. Let's see. Let's go to the unwrapping help again. Okay, maybe we need to tell it where to unwrap. So we will the dimension to operate along specified as a positive integer scale. If no value is specified, then the default is the first array dimension whose size does not equal 1. So unwrap 1 unwraps this way. I think we must tell it to unwrap this way because our phase shift images are moving that way. Maybe I should say unwrap 2. Okay, so let's try that. What's the syntax again? Come up, please. Okay. It's important. Unwrap, and then whatever this is, the tolerance, yes, and the dimension. Perhaps we should say this should be 2. Okay. Okay. Let's say that it should be along the second dimension. Okay, fingers crossed, guys. Not yet. It's not yet there. Bakit kaya? But the default is 1, right? So even if I don't put 1, it will do that, right? Oh, I'm rather confused about this. Okay. Okay, not this. Unwrap. Back tayo sa unwrap. There must be a better unwrapping algorithm here. Yeah. Titignan natin. See others. Okay. Hmm. We're nearly there. Unwraps. Ano pang sa unwraps? Well, I'm sorry. We're looking for... Teka. Okay, I don't know what's happening, but I'm gonna remove that flyover too. Okay. Again, one section. Oh, let's try this.
Sad times. Guys, I don't know what's happening, but the unwrapping seem not to be changing. But we can try and do this. Saglit, ha? Uh, I'll make my own unwrapping algorithm. Let me see. Fee. Okay. Diff. So what I'm gonna do is I'm trying to investigate. The unwrapping kasi, magdadagdag siya ng 2 pi kapag yung difference between here, let me show you. Ito yun yung face image natin. Pag nakadetect siya along this dimension na may difference between this value and tools, let's have a look at the data tips. So for example, di ba ito yung parang discontinuous yung color. In this part, the value here is 1.571. Wait, tama ba? Tapos, yung sumunod is, yung katabi niya is, not a number. Oh, that's why. I see. Okay. Alright. Not a number. That's the reason why. Nagkakaroon tayo ng not a number. Okay. Now I know why. Dapat dito pa lang dinoble na natin sila. You know why, guys? Because there can be instances when nagne-negative yung difference. And therefore, pag hindi natin sila i-denoble and we keep them as unsigned integer 8, it's very possible that any number na negative, hindi nila sinisiro lang nila. Okay? So I think that's the reason. Kaya tayo nagkakanot a number. Now let's run this section again. That's more pleasant looking. Tingnan natin kung hindi na siya with the tips. Hindi na siya not a number. Yun. And probably we can do this. Let's try this. Oh my goodness, it worked.
Yay.
Unwrap yung face natin. Now, what does this look like? You don't see the 3D. It's because if we display this as a mesh, guys, tingnan nyo ha, figure 4. If I display this as a mesh, it seems to be riding on a ramp. Ay, joke, masyadong excited. See object. Ito yung sinasabi ko. And actually, it's embedded there, but it just seems to be riding on a ramp. And the ramp is due to the fact that every phase shift, we put up to pi, and therefore, it will accrue. So, kailangan nating tanggalin tong ramp na to. So, how do we get this ramp off? We estimate. So, how do we estimate this ramp? There's a trick. I want you to go and let's look for non-uniform illumination. Para kasing this is like an image taken with a non-uniform illumination. Not that. To, non-uniform illumination. Yan. So this image is sana similar to what's our problem, no? Parang kita nyo madilim dito, no? Sa grains of rice. So the trick is gumawa siya ng estimate ng background. Yeah! And iyon yung sinubtract niya. O, di ba? So, how do you estimate the background? So, ang ginawa nila is they created a structuring element, a disc shape, which whose radius is 15. So, 30 by 30 halos, no? And what it did is they performed a morphological opening, and essentially it's tinanggal niya lang yung ito. Okay? Tinanggal niya to. And eventually nakakita niya yung background. So kumbaga nag-average lang siya doon sa nag-open siya. Actually we can just do an average no? An average. And then that's the background. Ta-da! There you go. We can do the same. There are many ways of doing this. The other way is creating dividing the field into several small sections and creating an average over that field. But let's try this first, no? I just need to ito, background subtract natin. Ganyan ang gagawin natin eventually sa Z. I'll create a structuring element and then I'll create a background on the Z using this structuring element. Simple as that. So let's try that. So, ito na. Normally guys, ang gagawin nyo, kukuha kayo ng image ng isang flat object. Tapos, iyon yung gagawin yung reference. Kasi ang flat object, pag in-unwrap mo yung face, yun na yung ramp na yun. So, yun yung ramp image na yun yung sasubtract mo. Okay? So, ano na nga ba uling ginawa niya? First thing is, gumawa siya ng structuring element of a disk. We can increase this if we want. Disk 15. Copy paste naman natin. Control C. Yan. Then, next yung ginawa niya next, gumawa siya ng background. Image opening lang. Sige. Natin to. Kaya na kaya ito? We'll just try this. And hindi I, kung hindi yung Zobj natin. Pero wait, ang tanong, ano yung Zobj? Ano yung tsura na? Hindi image open ang Zobj Ang Zobj ay, ano yung values niya? Clearly, hindi siya digital unsigned int 8 at baka hindi natin siya magamit. That looks nice. But let's see. Let's see if it works. I don't know if it will work. But anyway, let's run the section. Now, does it? I don't know. Kasi hindi siya naka-image SC. Sige. Try uli natin. Image SC. Baka. Size. Run section. Well, that looks like it, right? Okay. Let's hope this works. Insert a section. Get phase difference. And object na is Zobj minus background. Oh! And then figure 6 image SC Zobj. Okay, let's fingers crossed, guys. Oi, you see something? I see something. Okay? Medyo nasasapawan lang nito. Let's present it in 3D, shall we? Figure 7. I-mesh natin. Mesh. Remember, this is height map na ha. Ay, i-run nga pala. Run section. Oh! So, medyo nasapawan nung dyan banda, but I don't know if you can see it. Can you see that? Here. Can you see? Hindi masyadong kikita, but here it is. Here it is. Now, I want to get rid of this because this is kind of overpowering this depth here. And so what I'm gonna do is I'm gonna crop this off. How do we do that? So let's just display it from zeros to just 300. No? That's okay, that can be done. How do we do that? Simple. Let's go back here. Mesh obj. Again, look at obj, no? It's 342 by 321. When you want just to limit it to 300 by 300, then you just say, okay, row 1 to 300 and then column 1 to 300. That's it. And let's see. I hope this scales. So let's run the section again. There we go. Yo. Can you see that? That's the faint edge. Remember, this is medyo shallow, guys. Pasensya na, but this is really very shallow when you think about it. Okay, that's the height map. You see it?
Ma'am?
Yeah.
I think na-unplug po yata yung ginagamit yung headphones, sir, ma'am. So, humina po yung...
Is it? Do you hear me, Bea?
Ma'am, I can hear you naman po.
Ay, yan, nag-unstable lang po pala yung...
Do you see it, guys? That's the 3D part. Again, this is rather very shallow because this is some edge there. You see that? Isn't that nice? Oh, there's another structure here. Okay. Okay, that's it. We got the 3D. Maybe we can display this as a color map, a better color map. There's another way. We can remove all these pesky lines, no? Because these pesky lines are showing and they're obfuscating the structure. Let's do it again. There's a way. I think mesh. I don't know if it's surf or mesh. Help mesh. How do we remove the grid? Or is it surf? There's another kasi is surf. Let's just ask Google. How to remove grid lines in mesh plots in MATLAB. Yeah. Grid off. Okay, let's try that. Well, it's already here. I can do it in the command line. Let's see if it works. Grid off. Ay, joke. Baka ibang grid yung sinasabi niya. Tingnan natin, ha? Grid. Ay, hindi. Ano yun eh? Hindi yun. Not that. Yung sa mesh plot mismo. So, mesh natin. Yeah. Try kaya natin to. Tingnan natin tong ano, to. Kasi gusto natin ganyan, no? Okay. So, no, wait. Sir, edge color. Okay. Teka, is there another way to do this? Is there another way to do this? Edge color. Okay, wait lang ha. Meron yan. Promise. Okay. Okay, edge color. Black. Wait. Ayun. So, edge color. Dapat Okay. Got it. We will do it this way. S equals surf. Because mesh and surf. No? Mesh and surf can do the same. 3D. S edge. Ano sabi niya? Paano yung syntax? Importante to ha. Capital E, capital C. Okay. Because it's equals. Ano sabi niya? Naka-quotations ba guys? Naalala. Oo, naka-quote. Well, let's see. Yeah, wala na ata. Wala na. What you see here are just the pixel parts. Nawala na yung lines. Can you see it better? Sensya na ha, medyo shallow to eh. Shallow gravings to eh. But do you see it? Do you see this? Ayos ba guys? Hi, it worked. And it's 9:52, just on time. Ayos ba guys? We just made a 3D. And
Yes,
then you can
ma'am.
select different parts. You try it again, you go ahead, you rerun this again. Because the nice thing here is you can inspect the stone at different parts, just so crop other parts. No? What if we do run this again? Okay. Let's clear all, close all, everything, and then let's select another section. This was so well behaved. I'm surprised. You see, usually, merong mga parts na hindi mag-well behave sa unwrapping. But then, let's run the whole thing. So when I press run, not run section, it will run the whole thing. It will probably ask me for a file name. Indeed, it did. So let's call this face shape profilometry. Okay, add the path. Okay, let's select. What would I like to select? Maybe this part. Ito. Okay, maybe this. Let's take a look at this. Crop image. Hello, may error. I don't like that sound. Unrecognized function or variable reference. Lo, ano ba akong ginawang reference? Saan yan? Line 33. Ito. Joke. Mas ka dyan. Yan. Nabitin kami, Naka ba? Ano run natin tong section to. Nasa memory naman lahat Ano figure dapat yun? Ay, nag-run section. Hindi, dapat pati to. sa isang, naputol kasi dahil may mali dun sa isang section. So, ito na yung finale. Run section. Hello. Oh, and now, because I arbitrarily set the object and it's smaller than that. Oh, so again, this is not very good. Let's just, remove that. I did that on the fly. So run section again. Again, we have this kind of, but there, oh, that's much better. Have a look. Can you see? Can you see that? That's the writing. Ooh. Pero upside down siya, no? I mean, left side, left is right. Hindi siya image coordinates, naging Cartesian coordinates siya, guys. Okay. Normally dapat flip to eh. Flip. So let's limit it to 250 by 500. Hindi. Okay. All of this, but just up to 500. Ano na yung size niya? All rows, but maybe just 1 to 500. Kasi alam niya na merong umaangat doon sa lagpas ng 500. There you hindi, nandun pa din. Bawasan pa. Ano? 480. I'll be on the safe side. Selection. Yun! Okay, there's our 3D. You can see the graving marks. Yan. That's it. Ano to? Itong mga to, actually artifact yan ng pagiging non-linear ng ilaw. At saka pixels ng camera. Ng screen. So, sobrang zoomed in nung projector. Kikita mo yung pixel niya. So, this is actually pixel artifact. Yeah, you can see that, right? I'm happy. Hope you're happy too. Okay na tayo, guys?
Yes, ma'am. Thank you.
I'll stop share. So, kung gagawin nyo to, kailangan nyo ng projector, kailangan nyo gumawa ng sine wave na phase shifted by pi over 2. Project nyo sa image, capture, and then just do this. Ayos ba? We're done. And we are done for 187. So, hintayin nyo lang ako, pinapost ko na, sinisimulan ko na i-post yung mga tutorials. And anyway, don't worry, the deadliest deadline for the reports are last day of classes. The reports are the usual. Yung reports natin is slides. Slides, hindi paper, right? Ang slides lang. Huh? Okay, guys?
Yes, ma'am.
Questions?
Yes, ma'am.
Okay, hope you enjoyed it. Thank you. Bye-bye.
Thank you. Bye.
Thank you, ma'am.